Alrighty, guys, so we are ready for our second lesson in our parallel and perpendicular lines unit. And so on Friday, we learned about what the properties of parallel lines were. So when we had a transversal intersecting two parallel lines, we got all kinds of cool relationships going on. We had the correspondings, we had alternate interior, same side interior, alternate exterior, and same side exterior. And each one of those, they have special relationships. So remember your correspondings and both pairs of your alternate angles, your alternate interiors and your alternate exteriors. Those are congruent. All three are congruent. The same sides, the same side interior and same side exterior, those are both supplementary, meaning when you add them up, you will get 180. And so what we're doing now is we're going in the reverse order. Now we just have a pair of correspondings or alternate interior or alternate exterior. Now we have to prove that those lines are parallel. And we do that using those congruence or supplementary relationships. So here's what we're going to do. We're going to list all 5 of those things out and then look at the problems. And each one of these is called a converse of a theorem. A converse means it's like you take the 2 parts of the theorem and you reverse them. So think about it in like science. When you write a hypothesis, you say if something, then something. You take the 2 somethings and you switch the order. That's what a converse is in math. Okay, so here's for corresponding angles. So here's a picture, and these are a pair of correspondings. We know that because they are both in the upper right corners of their respective neighborhood. So this says if 2 lines in a transversal form corresponding angles that are congruent. When we first talked about these, our 2 lines weren't parallel. One of them was like cockeyed, which was clearly not parallel. What we're saying now is if it just so happens that they're parallel, sorry, I said that wrong. If the corresponding angles themselves turn out to be congruent, then that's enough to say that the lines are parallel. Okay, so we can say if angle 1 is congruent to angle 2, then line L is parallel to line M. That's how we write that. We're naming the lines by these lowercase scripts, and then we use the parallel symbol between them. So parallel is kind of like just 2 little sideways dashes. Okay, converse of alternate interior angles. So notice in our picture here, we've got 3 different angles, but the only pair that's alternate interior are 1 and 2. They are both inside L and M, and they're on different sides of our transversal. So if 2 lines in a transversal form alternate interior angles that are congruent, then the 2 lines are parallel. So we say if angle 1 is congruent to angle 2, then L is parallel to M in this instance. Okay, now converse of same side interior. So this time our same side would be 4 and 2 because they're on the same side. If 2 lines in a transversal form same side interior angles that just so happen to be supplementary, then we say that the lines are parallel. So I hope you're picking up on how this is related to what we did on Friday. It's the reverse of what we did. What we said on Friday, we said if 2 parallel lines and a transversal intersect each other, then the corresponding angles are congruent. Okay, so in other words, we said if this happened, so if L was parallel to M, then we said that those angles were congruent. So now we're saying it backwards. Okay, I hope that's making sense to you. All right, two more theorems or converse theorems. Oops, scoot that down a little bit. There we go. Okay, now the converse of alternate exterior. So notice in our picture, our alternate exteriors would be 1 and 2 because they're on the outside and opposite sides. If two lines that are transversal form alternate exterior angles that happen to be congruent, then the two lines are parallel. So then, if angle 1 is congruent to angle 2, then line L is parallel to line M. Oh, sorry, that's not L and M, that's A and B. Look at me, I can't even read. Then A is parallel to B. Wait a minute. I think I just made a mistake. Let me go back and look. No, I didn't make a mistake. I left something off. So I apologize for this bouncing back and forth. But on here, I forgot to put our if then. It's the same side interior. So if angle 2 plus angle 4 equals 180, which means supplementary, then L is parallel to M. I thought I forgot something. I'm sorry about that. I had to go back and add that. Okay. Last one, same side exterior. So in our diagram, that would be 1 and 3 because those are on the same side of the transversal and they're both outside. So if the two lines in a transversal make same side exterior angles that just so happen to be supplementary, then the two lines are parallel. And so we say if angle 1 plus angle 3 equals 180, then A is parallel to B. Okay? Now we're going to use all that stuff we just talked about, all these converse theorems. So in this problem, if angle 1 is congruent to angle 2, which of the lines must be parallel, if any? Justify our answer. So we have to name the lines that we think are parallel, and we have to use one of these converse theorems to back it up. Okay? So let's look where 1 and 2 are at in our picture. I like to label them. Angle 1 is right here. I'm going to draw through it. So, and then angle 2 is right here. Darken that in a little bit. Okay. So now, based on where these lines or angles are placed, we have to decide what's the relationship, and does that tell us anything specific about if they're parallel or not. So I'm noticing that both 1 and 2, they are touching this line DK. And so DK is acting as our transversal, okay? We didn't really talk about it on Friday, But if you think about it, all those relationships we talked about, corresponding, the alternates, the same sides, all of them, both angles touched the transversal, okay? So DK will be acting as our transversal line, which means that DE and KC could be the lines that are parallel because 1 and 2 are touching DK. So that means that the other two running this way could be our parallel lines. Now they told us that 1 and 2 are congruent. So thinking about these two lines being our options, notice that both 1 and 2 are inside those lines, so they're in this interior space, and they're on different sides of the transversal D to K. So that means they are alternate interior angles. And they told us they're congruent, and so using the converse of the alternate interiors, we can say they're parallel. So we'll say line DE. Remember, if you use a name a line this way with 2 points, you put the bar and your little line symbol on top, is parallel to line KC. And what's our reason? By the converse of the alternate interior angles theorem. And yes, you have to tell me that. So on a test, you'll have a problem like this, and you'll have to click or type in this or click it or whatever, and then you have to put the justification. You have to justify your answer. Otherwise, you're just pulling stuff out of thin air and you can't back it up. Okay, next one. If angle 3 and angle 2 are supplementary, which of the lines must be parallel, if any? Justify your answer. So, same diagram. Looking at angle 3, which is right here. Actually, let me back that up real quick. Here's angle 3, here's angle 2. Notice that angle 3 is obtuse looking and angle 2 is acute looking. That's the clue for the supplementary. So that we know these are different sized angles. And so I'm going to put 1 arc here and 2 arcs here. So notice that 3 and 2 are touching the line, but both of them are touching the line CK. That means that CK is acting like the transversal line. And so if the transversal is running this way, then the two lines that could be parallel have to go the other ways. So it's possibly EC and DK. Now they told us that 3 and 2 are supplementary. And based on their positions, 3 and 2 are on the same side of the transversal CK, and they're both outside the interior space. So they are same side exterior angles. And we know that those are supplementary. And because of that, that's enough to say that we have parallel lines. So we'll say that EC is parallel to DK by the converse of same side exterior angles theorem. Okay? I think I got one more like that. So let's go see what it is. Okay? So now I've given you a figure like this, and you could see some possibilities like this on your homework or test. So which lines or segments are parallel? Justify your answer. So now, notice where the 45s are at in relation to the two triangles. They're both touching MR. So what I like to do is I like to, if I don't have lines, make myself some lines. Just extend that a little bit. Oops, that went through it, but you get the idea. Extend the lines a little bit. And because those are the transversal, and I think that's the transversal, then that means that these two segments could be my parallels. And I know it's kind of hard to see this way, so it might help if you want to turn your picture so that the lines are almost flattish. That might help you see what's going on. So now I've got my possible parallel lines and the transversal. Notice how the two 45s are positioned to each other. One of them is inside the two parallel lines, or what I think is parallel. One of them is outside. That's your clue that this might be a corresponding situation, because both 45s are in the lower left corner of their respective neighborhood of the four angles together. They're both in the lower left. And so what we'll say is, now instead of using lines, the line symbol, because this was triangle, we'll use the segment symbol. So we're going to say segment CA is parallel to segment HR. And what was our reason? By the converse of the corresponding angles. And this one's a postulate, so you can just put post. I don't like the way I wrote that word. All right. So that's how you pick out who's parallel to who and your justification. Now what we're going to look at is, I've given you two lines, and we don't know they're parallel. We don't know at all. But what we need to do is we need to find a value for x such that it forces those lines to be parallel. Okay? Because in actuality, we could let x be anything. We could let x be whatever number we want, and that'll change the outcome. But if we find the specific value of x, that will force those lines to be parallel. That's what we're trying to do. So, if I wanted to be parallel, I need to first figure out what kind of relationship the angles have. So notice that 55 and x plus 25, they are, one's inside, one's outside. So this is a corresponding situation. They're both in the upper right corners. And what do we know about correspondings? They have to be congruent to be parallel. And so we'll just set those equal to each other. And we'll solve. And that's it. That's really all you do. Same thing. Notice the relationship first. These are alternate exteriors. And if we want L and M to be parallel, these must be congruent or equal. And so we'll just set them equal to each other. Now we'll subtract 2x. So we'll get x minus 33 equals 26. And we'll add 33. So x will end up being 59. All right, this last one I like to throw in because it's a little weird. So visually looking at the figure, we want L and M to be parallel. And we know that this angle over here is 105, and this one is the expression 3x plus 18, or minus 18. I need to figure out some way to manipulate that to get a relationship pair, or one we previously learned about. And so we sit and stare, and sit and stare, and sit and stare a little bit more. And hopefully you're thinking there's no way to get 105 and 3x minus 18 together, because the 105 is outside the space of the parallel lines, or what we think is the parallel lines. It's on the outside. The 3x minus 18 is on the inside, and they're on opposite sides. So we haven't learned any relationship like that, where one's inside, one's outside, and they're on different sides of the transversal. We haven't learned one like that. But what we can do is we can use another relationship. We can use a corresponding relationship to move this 105 up here, because this empty space right here and this 105, those are corresponding with each other. So we can bump it up here. So we first used a corresponding. Now we can do something, because this 105 and this 3x minus 18, if you'll notice, I can make a half circle with them. So we have to use a linear pair that we learned about way back in Unit 1. So this is kind of like a two-stepper problem. You have to move the 105 in a corresponding relationship and then realize that that's a linear pair, which means they're supplementary. So we'll do 3x minus 18 plus 105 equals 180. Now we'll combine like terms. Negative 18 plus 105 will get you 87. Now we'll subtract 87. 3x equals 93. Divide 3. X equals 31. All right. That's all I have. So I hope this lesson was helpful, this video was helpful. Make sure you watch it all the way through before you do your homework. Your homework, again, is on a digital format. Again, it's on Google Form. And as always, if you have questions, please let me know.